All right, thanks for that introduction. So the title of this panel is The Role of Multi-Agent Systems in the Rising AI Economy, How to Be AI Ready. But we're really just talking about frontier AI systems, where they're headed, how to think about them and their business impact. We have a great set of panelists here today for this theme. So just to set the context a bit, a few recent news items that really show the pertinence of this topic. You might have seen Klarna CEO claim that AI can now do the job of 700 customer service agents that they recently let go. They've automated a lot of that pipeline, and there's reasons to not take that exact number at face value, but the point is it's genuinely having an impact on a lot of industries already. Another example that really struck me was a startup called Cognition AI. They have an autonomous software engineer called Devin, which is basically an AI agent. This idea that you use a large language model like ChatGPT as the brain of an agent that can take actions like write software code and then execute that code and then iterate. Take the output of that code and feed it back into itself and keep going. And so that's the sort of thing that we're really addressing here. So I'll just briefly introduce our panelists and then we'll kick it off. So on my far left, we have Dr. Adrian Corbis, lecturer in innovation management and business economics at the University of Manchester. Next, we have Mayan Sheikh, who's the chief executive of Fetch.ai. Then we have Kerry Sheehan, the head of AI policy at the UK Government AI Regulation Task Force. And then last but not least, we have Professor Alessio Lamuscio, who's the CEO of Safe Intelligence and a professor at Imperial College London. So just a welcome to our panelists. Okay. So we have 30 minutes. I encourage you all to jump in fluidly and respond to your fellow panelists' points. So Humayun, why not start with you? You work on this stuff at the frontier. Can you tell us all what are multi-agent AI systems and how are they going to impact business?
So I think you mentioned quite nicely how this coder agent can code software for you. If you start taking that further, you need to see how one agent would interact with another agent. What that means is you have multiple stakeholders trying to achieve an objective of some type, and that's the beginning of a multi-agent system. So you can see we have all these LLMs which are coming up. We have more specialist LLMs which are coming up. We have a lot of software, AI, whatever you want to call it. They're building interactions, they're building actual software. Ultimately, what would happen is it would be a bit like what happened with the web. When it came, a lot of websites were made. But then what do you do when you have a billion websites? So in this case, what would happen is all these agents will have to start interacting with each other. And that's when you see the evolution of a multi-agent system.
One question is, there are AI agents today. In a primitive form, ChatGPT, you can hook it up to external tools. We have these GPTs that you can use. Some of them can interact with the internet. But so far, the technology seems like after a couple steps of reasoning, these models tend to break down. Do you have a sense of what is the outlook? When will we get multi-agent systems or even just singular agents that are able to do, multi-step complex tasks? What's the outlook for that?
These agents are going to get better and better. But the true test will come when they start interacting with each other. And when they start interacting with each other, that's when you see all this emergent behavior coming through. And I think that's when it becomes very interesting because multiple stakeholders will have their own objectives. And if you put them in a zero-sum game type of situation, how do they interact with each other? How do they actually achieve any consensus? Because that's quite important. So if there is a task which needs to be done where all 5 of us are involved, how do we achieve a consensus? What is the mechanism to get there? And I think these are all these interesting things. And also, ultimately, all these agents have to perform an action. They're doing the reasoning, they're doing the thinking, they're doing reinforcement learning. All of that is great. Ultimately, it has to do something. And when it comes to doing something, you need to provide it all the the network to connect with. So, for example, you can create a website, and if there is no way to search for that website, it's useless. So the whole point is we're going to see this evolution coming, where people have built single agent systems, and then they have to connect it to the multi-agent system, so they start interacting with each other. And that's really where I see this is going over the next couple of years. But ultimately, what's the objective is to create applications. I mean, if I bring it down to just real economic kind of outcome, you want to build applications. So you lay out your objective. That objective then translates into an application, and then you actually carry out those tasks. And that's really where we need to go. In terms of business and commerce, that's where we're going to go.
And last question for you briefly is, where are we going to see the impact first? A particular industry, a particular job, a particular task, where you see the gap closing fast?
It's difficult to say, but you can already start seeing. I mean, again, this is not necessarily just multi-agent systems, but you're seeing the impact of AI in Hollywood, for example. You're going to see, good and bad impacts. You're going to see fake videos. You're going to see fake news. All of that is happening. That's easy because that's somebody who can just, social media is connected, and you can actually deliver the results straight away, and millions of people can see it. So that's where the most impact is going to come in the short term. But ultimately, the whole e-commerce system of the Web 2.0 economy, that's going to have to change completely for this paradigm shift to really make an impact.
Yeah, all the websites will have to, I guess, be able to accept orders or inputs from agents doing things, running on the internet. Yeah, a big bottleneck to this effect or this world happening is how robust or safe our models are. So Alessio, maybe I'll turn to you next because you work on this. Can you tell us what it means for a model to be robust or safe enough to deploy an agent autonomously on the internet? And then maybe if you could speak to where we are in terms of progress on that question with LLMs.
Right. So yes, so that's really a technical question. So I think we're all familiar with the with the power of AI and the possibilities that are about to be unlocked by this technology. And in particular, like Umayyan has said, applications of AI into multi-agent systems are particularly important in this aspect. One thing to keep in mind for any model which is based on machine learning, whether it's a generative model, whether it's an LLM, or whether it's a standard machine learning model, such as an object detector, or such as something operating on tabular data, is that what we've known from research is that these models tend to be fragile. So what do we mean by a model that's fragile? Well, suppose that you have a model that's working exactly like you expect. Maybe it's an application for evaluating a scene such as this, counting the people in the room such as this. It seems to be working correctly for the particular image that we have right now. So unfortunately, what we know is that if we just change this scene a little bit, maybe just by dimming the light or adding a little bit of noise or maybe a little bit of camera shake, it may just be that the model fails. Okay? So what we mean by this is that the model could be fragile to possible perturbation in the input scene. And so this is one of the key technical problems that people have been struggling with to try and solve, both in terms of how do we assess the robustness or the anti-fragility of a model such as this, and how do we make the models better so that they don't fail in circumstances like this, right? So this is one of the technical challenges that people like me and others have been struggling with trying to solve, because as you can imagine, this is something that would unlock the deployment of multi-agent systems, but in general AI, in all sorts of applications, right? You don't need just to be thinking about safety-critical applications. In any application where there is an outcome which is at stake, you just want to have a model that's performing correctly. And so just to dig a little bit deeper on the technical side, we want a model that's performing correctly, both what we call in distribution, so whenever the data is in line with your training data, but also ideally we want to have a model that we don't need to replace every single time the data runtime in which it's operating is a little bit out of distribution. Okay, so again, if I train this model on these lighting conditions, I'd like this model to be working correctly if we dim in the light a little bit, or it becomes a lighter sunset. Okay, so right now and up until I would say a few years ago, people were just testing their system and stress testing their system just going a little bit towards what possible solution we have to this problem. Unfortunately, this technology is inherently limited in terms of what you can achieve, because as you can imagine, the input sets are infinite, they're dense, it's very hard to get assurance on the performance of the model. There's new technologies coming up, such as verification and robustification, that enable us actually to give a precise and trustworthy assessment of the robustness of the model and considerably improve the robustness of the model. And so these are technologies that are being looked at in aviation, in other sectors, including in finance, to be able to deploy these models in a robust and trustworthy way.
That's really helpful technical overview. What's your sense of, I guess, the outlook for this? Do you think that on a 5-year time horizon, I know it's very hard to predict, but that these are solvable research problems, or do you feel that some people say that with LLMs in particular, for example, because it's a feature to an extent that the output is somewhat unpredictable, that kind of unlocks creativity in a model, that maybe we can't ever get to some kind of provably robust world where it never makes a mistake, for example?
Yeah, great question. So, if we're doing this panel like 4 years ago, we'd be able to, in terms of verification, we'd be able to verify models in the region of 10 to the 2, 10 to the 3 kind of neurons in the system. Now, the good news is that the academic community has been conquering one order of magnitude in terms of scalability every year. And we're now at the point where we can actually verify the robustness or, for example, object detectors that are maybe looking at the runway and trying to assess whether or not they're robust against possible incursion on the runway and so on. So the technology is moving very fast. There are already some applications, for example, things like Fetch.ai are looking at that we can already potentially assess. If we're looking at LLMs, that technology is not powerful enough to be able to assess LLMs just yet. Years down the line, potentially, right now we cannot verify LLMs.
Okay. Did any of our panelists have any reactions to this? Because I want to shift a little bit to the kind of economic policy set of questions. Okay. So, Adrian, maybe I'll turn to you next, because what Alessio just mentioned, this idea of robust behavior. This is a bottleneck to adoption, to business impact, right? And you study businesses and their ability to innovate. Could you give us a sense of what are the other barriers to adoption of AI systems, whether multi-agent or just generative AI in general, and how does that influence your assessment of the economic impact, if it's going to be transformative, or if it's going to be more like the internet, which was obviously impactful, but maybe it was gradual over a long period of time?
Yeah, so the thing is that we don't know the impact, and that will be the first bottleneck. Is businesses face this chicken and egg problem. It's very difficult to make this adoption decision if you don't know use cases, if you don't know the value you're going to generate with these different technologies. And the other way around, those technologies, their real potential is only going to appear when you implement them in the organizations, because we have to change the mindset, and that's really the bottleneck. We tend to think about radical technology within our existing mindsets, so we tend to see them much more incremental way to just slightly improve the way we do things. But the real potential takes years to really be revealed. Because you need to bring it into the organization, let the employees, let the managers kind of hack the technologies, play with it, and really discover the different source of value. And another bottleneck, I think, that is much more specific with AI is really integration. So it's not 2000. So nowadays, most businesses start with existing IT systems. So to me, a very important question for this kind of technology is who's going to bring it to the businesses and to the consumers and so on. Is it Microsoft and the existing provider of your IT systems in the organization, or is it going to be a new player that's actually going to challenge and change how things are being done? And that's how industries have changed, and that's how big players have disappeared over the years. So I don't want to make any prediction there, but the bottleneck at the moment, there's a lot of wait and see, because shall I trust my existing partner, the existing businesses providing me with my IT system, or shall I go to a new, more entrepreneurial venture, again, not knowing the impact? And finally, there's trust, because talking about frontier AI, I'm not thinking about LLM, I'm more thinking about the kind of decision support system that can take decisions for us. So not just automation, but really, data-driven decision making, this kind of tools. And with this kind of with this kind of tools going into the boardroom, going into the C-suite, there's a big question is how much do we want to trust a machine? I mean, we know studying business that the symbolic role of manager is generally to embody the decision and to be the person responsible for the decision. Once it's made by a machine, even with the best evidence, with the best data, how do you motivate employees going towards this objective if it's a computer who's done it? So I think that's my third bottleneck.
That's super interesting. On that second one of going to a large enterprise cloud vendor, for example, who's very experienced working with companies or a startup, where does it look like right now? It seems like you would expect the cloud providers to have an advantage here, but maybe not. And Humayun, if you have a thought on this, being embedded in the industry.
I think the points are quite valid, but there is a middle ground, right? So you are starting to integrate things. So you're starting to see change. You don't have to take it to the decision making, but you can actually start with interaction. You can start with, as you said, the tools. So people are interacting with the tools, and you can, in a very controlled manner, enable these tools to actually interact with each other, and then you have to monitor the results. So there is a lot we can do, and that will improve the efficiency, that will improve it might not change the decision making yet, but it can definitely help with decision making. And I think it's those menial tasks of, just a very simple example, perhaps it doesn't always have to start from enterprise. It can also start from individuals. And we've all done it. Try and look for a plumber, for example. I'm sure everybody's done it in their life once in a while. It's a nightmare. The onus is on you to actually go and search. But the whole search system is going to change. And when the whole search system is going to change, the peripherals, the different enterprise which surrounds that search system will start to change. So I think that's, to your point, which is a valid point, I think we're going to not know, and slowly we will start adopting it.
Yeah. One more question about the economy, and then we'll turn to regulation. I'm just curious. It seemed like your assessment, Adrian, was relatively sanguine, right? You correct me if I'm wrong, but there's progress, but there's lots of hurdles along the way. And I'd just be curious if any of our other panelists, have either an outlook that's a little bit more, hey, this thing's starting to take off, we're going to see very, very big economic impacts, or do you think it'll be even slower? If any of our other panelists have a view on that question.
Oh, there you are.
So the midterm economic impact.
Yeah, it seemed like your view was we have these hurdles, and we are slowly getting over them, but it's uncertain and it'll take a lot of time. Do any of our other panelists have do you think it'll, the adoption or diffusion of?
I think we'll see it from the grassroots. I think we'll start seeing change in people's behavior, because if you look at OpenAI, what OpenAI did was it put it in front of individuals who can just use it. It didn't need to be an enterprise. Enterprise comes the last, because there's no way enterprise is going to jump into it. So my feeling is we're going to see this change from the grassroots. We're going to see it from individuals who want to play with the technology. Yeah. They will improve it.
Consumers and startups, yeah. Okay, let's turn to regulation, which is a super important in terms of adoption as well. So, Carrie, turning to you, because you're right in the thick of this, could you just give us a sense of how regulators are thinking about of this question of whether it's autonomous AI agents or Gen AI in general? And I mean, for some context, we've for I think a year now we've had the UK's AI principles, like a framework, and then very recently we got the EU AI Act, and I'm sure people are aware of this, but maybe if you could also just to orient everyone in terms of what these say at a very high level, and maybe what the key differences and approaches are.
Yeah. So regardless of what AI system you use, whether it's autonomous multi-agent or not, you will have to adhere to regulation in whichever jurisdiction you're operating in, and that could actually be 2 or more jurisdictions, so it's going to get quite complex. There'll always be a healthy tension between the academics that we work quite closely with as to why are we doing this, and we say, well, we need to do this, we're going to get on and do this. And just picking up on your point on economic drivers, the UK, for example, has identified AI as one of the top economic drivers. attract inbound investment, of course. Technology companies move in, markets thrive, and so forth. So going back to the UK's basis for AI regulations, you're quite right. The UK's AI white paper was put out to consultation last year. Hopefully some of you fed into that. The response was published February this year, and it outlines the regulatory approach, which is for the government to hand it down to current regulators. You do the work and we'll basically tell you if that's the right way or not. So regulators are currently coming to the end of 6 months discoveries, so mapping use cases in the regulated sectors and the emerging use cases and where the future thinking is, for example, and then moving all the way to looking at what guidance would need to be produced, possibly by at the end of this year. So as you've mentioned, there is the UK principles-based approach, which will hopefully support the pro-innovation aspects. There might be some nuance in that. Many regulators, of course, don't dictate how you do things. They just want to make sure that the outcomes that you are achieving meet those principles and meet the regulatory requirements. So, you know, as Dr. Adrian has just said, you know, the outcomes may be a bottleneck or there's a clear conflict regulatory, you will have to account for the outcomes. Some regulators may not want to say, let's have a look in that black box, but you will have to prove, you know, that you have got safe, secure, robust systems. They are explainable, for example, and then you move over into transparency. So I would strongly recommend understanding those principles. There are statements which back up those principles on gov.uk. They've been available, like you said, for the past year. That should link to your governance and risk strategies, for example. And then also, how do you correlate those if you are transcending into the EU AI Act jurisdiction, for example?
Yeah. Could I ask, there's a perception that the EU's approach to this is a little bit more risk averse and the UK's is more pro-business. Do you agree with that perception? You know, how do you see yourself interacting with other regulators on this?
Well, I'm not going to get into saying which one's right or wrong. I need to get out of here alive, so to say. But all jokes aside, it has to be safety first. So they are both similar in that aspect. And, you know, the principles-based approach or the high-low risk rules-based approach, you're going to have robust risk governance practices in place anyway. And in fact, they are an extension of what you should have in place currently.
But perhaps I can take a little bit more aggressive role on it, you know, without hopefully not offending anybody here. I think the issue is, and we've seen it in some regulations, you know, over-regulation is going to stunt completely the development. We're not going to figure out, and you know, we have some time to figure out what is happening in the black box. So I think that approach in my mind is completely not going to apply. Over time, we're going to fail. Or if we don't fail, it will take a long time to kind of understand it. What, you know, if you look at it in a completely different way, which is, okay, well, this black box is doing what is it doing? It can be giving information. You can control that information. Where it actually connects with other systems, you can control the boundary where the interface is, where the actions happen. So if you regulate the action space, you have much more of a chance. If you try and regulate the training space and trying to understand what's happening in this whole, you know, even if you take an example of generative AI, you can't control, I mean, and if Google can't control it and they made a complete mess of whatever happened, then who else is going to control it? And that's my biggest worry. However, what you can control is where do these, you know, interact? Where's the action space? So if you patrol the action space, that's a much more impactful kind of area to patrol than you know, stopping the academics from researching or trying to justify why they did that.
That makes sense. So more focused on the outcomes and impacts rather than inputs. Though I guess there is a slight difference between saying that, hey, you're not allowed to hook up an AI agent to, you know, a specific set of you know, applications. For example, you can't hook it up to you know, a biology wet lab because we're scared that it'll make something bad. Versus, oh, you're just not allowed to produce something bad, if that makes sense. So
But you can create some audit mechanisms, right? You can say, okay, if this agent interacted with X, Y, and Z other agents, where was the interaction? How did you record it? Why did it actually happen? And can you control it? If you need to stop it, how do you stop it?
yeah.
Yeah. And also, just to pick up on that, I think most governments will start to have AI risk registers. So if you are in the AI risk registers, so some of that will sit with the regulators, but also from a country regulatory jurisdiction level. So what is in that very top high risk categories and so forth? Because obviously you're talking about national infrastructure, privacy security, policing security, national security, and so forth.
So you would register the tasks or applications that are high risk versus low risk. Okay, I see what you mean.
Yeah.
I just wanted to, going back to the multi-agent, I think as a technology, it has some advantages when we talk about black box and these kind of things, because they're much easier to read, because we're really afraid when we look at LLM because nobody can understand what's happening. So that's when we start wondering, oh, there might be biases and things like that. But with multi-agent system, you really have a distributed architecture that can mimic individual decision, individual behaviors, so you can track them, you can explain them, you can understand them. And for instance, you could use them to develop digital twins of organization, processes, production process, improve sustainability of processes, and being able again to open the box and use standard statistical techniques to understand the reasons behind this behavior. Mm. So different AI create different things, so we cannot get a single regulation without the technology.
But then just picking up on that, there are regulatory sandboxes already available in the UK. Some of the regulators have them. For example, the FSA, the Financial Services Authority, some of the banking corporations uses them, supported by tech companies and data specialists, of course. And I think we'll just see that more going forwards, almost like the playground. Come and use the elements of the gym. The regulator won't necessarily tick it off as safe, because obviously that's not what the regulator's role is, because that's a legal duty. There'll be white labelled sandboxes, of course, but that is an approach that's being taken forwards.
Maybe I can also jump in here. So, from a kind of practitioner's point of view, one, sometimes, talking about, the issues of assessing robustness, safety, and can we deploy or should we hold back? There is sometimes, from people, from the developers and people who are out there deploying, a little bit of lack of clarity on their side in terms of what should they do to satisfy themselves, the insurers or the regulations themselves, whether or not a system such as this is deployable. So there's been a lot of emphasis on how the data is curated, how the data is collected, and so on, and that comes traditionally also from the academic side, and there's all sorts of work that's now been done to assess actually the model itself. Ultimately, when, what gets executed is not the data, what gets executed is the model. So I think we really need to move into a direction where we have protocols, guidelines in terms of how we do a robust assessment of the product itself before it gets deployed. And there is a lot of science and engineering. When we build a bridge, we can do calculations, understand whether the bridge is going to stand up or not. We're way past that point. And we fast approaching the point where we can do that for AI systems and multi-agent systems. In fact, in some cases, we can already do that, and perhaps we're missing the trick there. Yeah. Should be really well connected to the new technological advances there.
And just to also pick up on that, the nuclear industry, heavily regulated, very high risk. Some of their risk assessments are quite robust. There is a hell of a lot out there already.
Yeah, absolutely.
Yeah. And it sounded like the kind of robustness checks or evaluation, so forth, that's what would be upcoming over this year. Is that right, Carrie, that you were saying earlier?
Yeah, so by the end of April, 30th of April, all UK, GB regulators have to publish their strategies on gov.uk, their responses to the directive of the UK AI white paper, and that will set out their approach to AI regulation. Some of the regulators will put out high-level summary strategies, and at the beginning of April put out call for inputs for various industries to assess whether their suggested approach is the right approach. And then following that, they will enact those AI strategies and look to produce guidance by the end of this year. It will be an iterative approach. This is new territory for regulators. Obviously, there has to be a slightly more agile, adaptable mindset because of the way that technology is moving as we go forwards. But yeah.
All right, well, we're over time. But with that, we got a great sense of, where this technology is headed, what's at the frontier with multi-agent systems, and, how government may be responding to that. So thank you again to our panelists. That was great.
Thank you.